Hello children, welcome to Right Tuition Classes, lecture number 3 for extra questions, okay? We are doing extra questions of similarity chapter. I've done some 7-8 questions in the beginning of the first two lectures. Now here I start with the 8th one. Like in triangle ABC, angle B is 90 is given to us. BD is perpendicular to AC is given to us. Then AD, the length of AD, all can see this length of AD is X. Length of CD is Y. Then they give BC is A, AC is B, AB is C. All these are given to us, okay? And what they want me to prove that 1 upon xy equal 1 upon c square plus 1 upon a square. Then when you look at it, children, one get an idea, okay, how to get this. What is the c square? C square is nothing but AB square. I want AB square. And down here, A square, I want BC square. Basically, I want AB square. I want again BC squared. And again, I want it in the denominator. I want it in the denominator. I want it in the denominator. So basically a ratio form. The moment I come across a ratio, only one idea comes to me. That it must have been similarity, because once the triangles are similar, we have learned corresponding sides are in proportion. That means the ratio of the sides you get. And in the ratio of the sides after cross multiplying, perhaps I can get AB squared. But where is similarity here, children? Yes, one theorem we have learned. Similarity in right angle triangle. Like, can you see a big? You can see that. It's there, okay? Can you see a big right angle triangle? Correct? Triangle ABC. 2-degree angle B is 90. And from the vertex of the right angle, a perpendicular segment is drawn to the hypotenuse. Got it? Again, I repeat, there is a big right angle triangle. Can you see angle B is 90? And from the vertex of the right angle, a perpendicular is drawn to the hypotenuse. In this triangle ABC, angle B is 90. And from the vertex of the right angle, a perpendicular is drawn to the hypotenuse. The moment you see this, immediately the idea comes to your mind. All the three triangles are similar. All the three triangles formed in the figure are similar. There are three triangles. One is the original triangle and two triangles on either side of the perpendicular. Got it? So all these three triangles are similar. I hope people are getting me here. Like what I'll do, I'll just show it to you, children, how I present this. Okay, please keep it in your mind. Like, how do we present this? Similarity in right angle triangle. All the three triangles are similar. Look here. First, the triangle's name in triangle ABC. Then the 90-degree angle. Why this 90-degree angle? Why this 90-degree we have to write? Okay, where to all to write this 90-degree angle? When we write this 90-degree angle, children, then only it becomes a right angle triangle. Means to the reader, they understand that this is the right angle triangle. Okay. To the reader, whoever reads it will realize this is a right angle triangle. In triangle ABC, angle B is 90. That means this is a right angle triangle. And also you see one condition, okay? Segment BD is perpendicular to hypotenuse AC. This condition also is seen. Whenever these two conditions are seen, children, right angle triangle from the vertex of the right angle perpendicular is drawn to the hypotenuse, then all the three triangles are similar. तो बड़ा triangle का नाम कैसे लिखूंगा बेटा? बड़ा triangle का नाम लिखते वक्त I'll always take care. The vertex of the right angle as a middle letter. Vertex of the right angle as a middle letter. So triangle ABC. Vertex B is a middle letter. I can write ABC or CBA, my choice, okay? We write ABC. Now, first two letters are AB, okay? Am I right? Now tell me, for this small triangles, which is the vertex of the right angle? Don't you agree D? जैसा बड़ा ट्रायंगल के लिए B था वर्टेक्स ऑफ द राइट एंगल, ये दोनों छोटे ट्रायंगल के लिए D है, D वर्टेक्स ऑफ द राइट एंगल. तो ये जो पहला दो लेटर है वो दोनों के बीच में आपको D डाल देने का, तो दूसरा ट्रायंगल मिल गया ADB, बिकॉज वर्टेक्स ऑफ द राइट एंगल मिडिल लेटर मैंने बताया. अच्छा वापस प्लीज आप देखिए, सेकेंड एंड थर्ड लेटर BC है, BC उसके बीच में D डाल दो, तो ये हो गया ट्रायंगल BDC. So ये तीनों, please have a look. I call this as one, okay? And by similarity in right angle triangle, by similarity in right angle triangle, by similarity in right angled triangle. Are you getting me? By similarity in right angle triangle, I put a symbol for triangle word, okay? Now you can see here, children, I got this. But आपको पहला AB square मांगता है बेटा. AB square कौन सा दो ट्रायंगल में AB is a side. आप फिगर में भी देख सकते हो. AB square मांगता है तो AB should be a side of two different triangles. AB square चाहिए, AB square जिसका भी square चाहिए ना वो सेगमेंट कौन सा दो ट्रायंगल का साइड है. तो AB square चाहिए तो ABC और ADB. ABC बड़ा ट्रायंगल का AB साइड है और एक छोटा ट्रायंगल का ADB का साइड है. ओके, so what I'm going to do, I'm going to rewrite those two triangles, triangle ABC, similar triangle ADB, and I call this as from 1. Got it? From 1. Now, when these two triangles are similar, children, to get AB square, I know the corresponding sides are in proportion, but the ratio of the corresponding sides are equal. पहला दो letter AB upon पहला दो letter AD. AB upon AD equal BC upon DB equal AC upon AB. You can see here, this is corresponding sides of similar triangles. Corresponding sides of similar triangles. Children, I write short form. You're going to write full form, okay? Otherwise, this space is not enough for me. Now, when you look at the first ratio and the third ratio, AB square मिलने का चांस है इधर, AB square मिलने का चांस है, AB square मिलने का चांस है इधर. So I think I'm going to rewrite AB upon AD is equal to AC upon AB, the first ratio and the third ratio. And then therefore AB square equals AC into AD. AC into AD, and I call this as 2. Now the way I got, I want BC square, children. So I think 1 upon AB square if you want. Sorry, I would like to somebody saying, okay, like I'll say 1 upon, why not get it as 1 upon AB square? Why keep it like this? Why not get it as 1 upon AB square? So come on, no problem. 1 upon AB square equals, क्या आएगा? 1 upon, because product term is one term. So 1 upon AC into AD. No problem. Now, I call this as statement number 2. Now, I want 1 upon BC square. How can I get BC square? How can I get BC square? BC को देखो, BC को देखो. कौन सा दो राइट एंगल ट्राइंगल का साइड है? एक बड़ा ट्राइंगल का ABC का है और दूसरा एक छोटा ट्राइंगल BDC का है. So today, triangle ABC, similar triangle BDC. Why am I saying children? I'm saying this from 1. From 1, okay? And now look here, once the triangles are similar, corresponding sides are in proportional. AB upon BD equals BC upon DC equals AC upon BC. The reason is corresponding sides of similar triangles. Corresponding sides of similar triangles. Again, children, when you look, I want BC square, 1 upon BC square. Don't you agree? If I take the second and third ratio, I can get BC square. So I take the second and third ratio, BC upon BC equal AC upon BC. Then I cross multiply, BC square equals AC into DC. And I call this as statement number 3. Now, I will not call this as statement number 3. I better bring it in the form of, please have a look, I better bring it in the form of 1 upon, like I'll bring it in the form of 1 upon BC square. So 1 upon BC square, and here since it's AC into DC, product is there, this one term. So the whole thing 1 upon AC into DC. Okay, I call this as statement number 3. Now you want 1 upon C square plus 1 upon A square. 1 upon C square plus 1 upon A square. This ABC square and BC is A square. So what am I going to do? Adding, when I add, adding 1 and 2. When I add 1 and, sorry, adding 2 and 3. Adding 2 and 3. Adding 2 and 3. When I add two different statements, children, people should know The left-hand side gets added up. The right-hand side gets added up. To the left-hand side, so 1 upon AB square plus 1 upon BC square. And right-hand side, 1 upon AC into BD. AC into AD. AC into AD. I'm so sorry. It should be AC into AD. AC into AD. 1 upon AC into AD plus 1 upon AC into DC plus. Now, people know, children, can I write this in small letters, whatever they use? Therefore, 1 upon this ABC square plus 1 upon A square is equal to 1 upon AC is BXB and AD is X. And here 1 upon BY. You can see what is the LCM, children. 1 upon C square plus 1 upon A square is equal to LCM is, when you look at it, children, BX, BY. So B is common. B is put BXY. So this BX, to make it as BXY, I'll have to multiply by Y. So 1 into Y is Y plus this BY. To make it as BXY, I'll have to multiply by X. So 1 into X multiplied, okay, on top. And now when you look at it, children, but AC is AD plus CD. AC is X plus Y. I hope people are getting me here. So what will happen? Let me put, please have a look here. AC is nothing but B. So, but please have a look at 1 upon C square. Sorry, I'll write it here. This is my, what I can say, I can call this as statement number 4. Now, look here. Look at the picture, children, again. Don't you agree? What is AC, children? AC is AD. Just have a look. AC is, so sorry, children, AC is AD plus CD. A dash, D dash, C. Therefore, AC is nothing but B. AC is nothing but B. Therefore, what I get? Therefore, B equal X plus Y. I call this as phi. Now, in place of X plus Y, can I put B? So 1 upon C square plus 1 upon A square is equal to B upon BXY. And you can see BB gets cancelled. This is from 4 and 5. And what should be the last line? The proof, that is 1 upon C square. Therefore, 1 upon C square plus 1 upon A square is equal to 1 upon XY. I hope people understood me here. Not a difficult sum, children. You'll have to concentrate. Pause the video, go through it again twice, and then try to write it down. This is what you have to do with every sum. Understand it, and then try to write it down. Okay? We go to the next sum, children. The next sum is question number 9 of ours. So, question number 9. In triangle ABC, this PQ is intersecting AB and AC in P and Q. That is what in short it's written. A dash P dash B. मतलब PQ का P lies on AB. PQ का Q lies on AC. A dash Q dash C. मतलब PQ is intersecting AB and AC in points P and Q. This PQ is parallel to BC. PQ is parallel to BC. This segment AD is a median. Segment AD is a median of triangle ABC. That means a median always joins the midpoint of a side to the opposite vertex. So when they say AD is a median, A is a vertex. That means D is the midpoint of BC. Now you want to prove this AD bisects PQ at E. AD bisects PQ at E. E has been named here. I want to prove PQ bisects AD at E. Okay, now tell me, when can I say AD bisects PQ at E? When PE equals QE. If PE and QE are equal, PE and QE are equal, then only you can say Then 4, segment AD bisects PQ at B. But the question is, children, how can I get this P? ऐसा क्या करूं फॉर्मूला कौन सा सोचूं जिसमें पी क्यू पीई आ जाएगा this p which I want equal this p which I want okay which I want this p what I marked here okay in which how can I get it in what how can I get p here so one simple thing comes to your mind children whenever you see like this pq is parallel to bc you know, the big triangle, I can easily prove triangle APQ, similar triangle ABC should come to your mind. Even in the small triangle ABD, I can prove APE, similar triangle ABD. So if I want P, I think I should prove APE, similar triangle ABD. APE, similar triangle ABD. I should prove this yellow, this pink triangle. I want to prove this pink triangle similar to this pink triangle similar to this pink triangle which you can see. I want to prove it is similar to ABD. Now, how can I prove it, children? When you look at it, you can clearly see they have a common angle. And one more pair of angles they require. Yeah, that you can get it from the given information, parallel lines. PQ is parallel to BC, look here. PQ is parallel to BC. So what happens is, children, if PQ is parallel to BC, in my proof, I can always get, if PQ is parallel to BC, this angle APE equal angle ABD, I can always say by converse of, by corresponding angles here. Got it? When the lines are parallel, corresponding angles are equal. So now look at a pink triangle. Two angles of the small pink triangle is equal to two angles of the big triangle. So naturally both are similar. And once the triangles are similar, corresponding sides are in proportion. मतलब ratio of the corresponding sides चाहिए उसमें PE मिलेगा, उसमें PE जरूर मिलेगा. So what am I going to do, children? Just simple. I'm going to use that. Look here, children. What I see? First I see segment PQ parallel segment BC because my way of writing a proof is always whenever we get angles congruent with the help of parallel lines, I'll show it always separately if I'm going to use them. So I'm going to use this PQ parallel BC as the corresponding angles I'm going to use. So separately I'm showing segment PQ parallel segment BC on transversal you can see here. On transversal AB. Angle, I just call it as APE. Congruent angle ABD. I'm going to use this. Got it? I call like this. Call it sheet number 1 by corresponding angles theorem. When the lines are parallel, corresponding angles are equal. That theorem is called corresponding angles theorem. Also, here also, just like this pink triangle, this small triangle, AEP, AEQ, I want to prove similar to ACD. So I'll be using up these two angles. Okay, so I better get it. On transversal AC, angle AQE, congruent angle ACD, statement number 2, by corresponding angles theorem. By corresponding angles theorem. And now I am going to use both of them. That's why I numbered it. Okay. Now first I'm going to take the pink triangle and the big triangle. In triangle ABAPE and triangle ABD. You can see the two triangles, children. APE and ABD. Angle APE congruent angle ABD from 1. Then angle PAE, congruent angle BAD. What's the reason for this common angle? So don't you agree both these triangles are similar by, therefore triangle APE, similar triangle ABD by A test. Now I want my AE, got it? So see how I get it. AP upon AP upon AB is equal to PE. Oh, this is what I want. Actually, I was chasing PE. I want PE. This PE upon BD equal AE upon AD. I can call this as statement number 3 and give the reason as corresponding angles of similar triangles. In the same way, I can prove now this triangle AQE and triangle ACD. In triangle AQE and triangle ACD. You can see it clearly, children. Angle AQE, I've got this. Angle AQE is congruent to angle ACD from 2. Angle QAE, congruent angle CAD, common angle. The triangle AQE is similar to triangle ACD by AA test of similarity. Now, once the triangles are similar, the corresponding sides are in proportion. First two letters AQ. What are the first two letters AC? Here, QE. Oh, this is what I want. Actually, QE I want. QE upon BC equal AE upon AD. This is my statement number 4. Reason is corresponding sides of similar triangles. And now, when you look at your statement number 3 and 4, you can get your answer. You see here, I've got on the right hand side, extreme right hand side, AE upon AD. Here also on the extreme right hand side, AE upon AD. So naturally, the right hand sides are same. So the left hand side, that is PE upon BD equal QE upon CD. Now, why did I? Because I want P and QE. So I only take the ratio involving P and QE. So P upon BD equal Q upon CD. Can I say from 3 and 4? Now you can see, children, P equal P, okay, P upon QE. Actually, this need not be done. P upon QE equal BD upon CD. But BD equals CD. D is midpoint of BC. So what happens, children? Therefore, PE upon QE equal 1 upon 1. If I call this as 5 and if I call this as 6, I'll say from 5 and 6. Therefore, P equal QE, cross multiply. And if P and Q are equal, I can write this answer. Therefore, AD bisects BC at D, children. At E. I'm so sorry. What did I write? AD bisects PQ. AD bisects PQ at E. So when you look at this, children, I don't think this was again difficult, but this You have to use the presence of mind, okay? Your mind should work. And the presence of mind comes only after practice, children. I'm not saying these are the sums which are going to come in exam, but I'm just trying to show you the way of thinking so that you develop a right approach for solving the sums, okay? We go to the next sum, children. Now, question number 10, children, very simple. There is a right angle triangle ABC. Angle B is 90, you can see here. On the hypotenuse AC, you can see one triangle ARC is an equilateral triangle. On the two perpendicular sides AB and BC, again, you can see equilateral triangles PAB and QBC. And what did you prove, children? Area of this big equilateral triangle on the hypotenuse ARC is sum of the areas of the equilateral triangles on the remaining two sides, APB plus QBC. Very simple, children, I feel. Remember one thing, children. All equilateral triangles are similar. All equilateral triangles. See, triangle ARC, triangle APB, and triangle BQC. What is that? QBC are equilateral triangles. Are equilateral triangles given, because in all equilateral triangles, all angles are 60. The reason is given. So naturally, therefore, triangle APB, the small triangle APB, is similar to the big triangle ARC. Purposely, I take like this. Okay? All equilateral triangles are similar. If the equilateral triangles are similar, children, then what is the theorem on area? Because it's an area question, area. Therefore, area of triangle APB upon area of triangle ARC, be smart enough to involve the sides. You know, area upon area is side square upon corresponding side square. I'll involve the corresponding side squares, okay? AB square upon AC square. The sides of this equilateral triangles, okay? Like by theorem on, this is my statement number 1, by theorem on areas of similar triangles. By theorem on areas of similar triangles. Again, children, triangle QBC is similar to triangle QBC is similar to triangle ARC. All equilateral triangles are similar. All equilateral triangles are similar, children, because their angles are going to be 60 degrees. Therefore, again, area of triangle QBC upon area of triangle ARC should be equal to square of the corresponding sides, AC square, sorry, QBC is what it will be, children. You can say BC square upon AC square, again, by statement number 2, by theorem on areas of similar triangles. By theorem on areas of similar triangles. Now, I've used my common sense, children. I'm going to add area of triangle APB upon area of triangle ARC plus area of triangle QBC upon area of triangle ARC is equal to AB square upon AC square plus BC square upon AC square. Adding, I'll just say adding 1 and 2. So somehow I got area of triangle APB plus area of triangle QBC. Now denominator is same, children. So area of triangle ARC upon area of triangle APB plus area of triangle QBC. When the denominator is same, numerator gets added up. Here also, when the denominator is same, AB square plus BC square upon AC square. Now what is happening, children? Please have a look at this. AB square plus BC square is nothing but AC square by Pythagoras theorem. So area of triangle APB plus area of triangle QBC upon area of triangle ARC is equal to, can I say AC square upon AC square? Reason, since AB square plus BC square equal by Pythagoras theorem equal AC square. See, AC square gets cancelled, children. What are left? 1. So the last line, I'm going to write it on top, children, with some other color. You can see it here. Therefore, ये लास्ट लाइन इधर लिखा हुआ है, लास्ट लाइन तो याद रखो क्या है. Okay, people should know. So area of triangle, what will happen, children? Area of triangle APB plus area of triangle plus area of triangle QBC upon area of triangle ARC is equal to 1 upon 1. Your AC gets cancelled. So ultimately I get my answer. Therefore, area of triangle APB plus area of triangle QBC is equal to area of triangle ABC. I hope is equal to area of triangle ARC, sorry. So I hope everybody has understood. Okay, quite a simple proof. I don't think it's difficult, children. If you would have concentrated, I'm sure you would have got it. Okay, I'm sure you will get it. Okay, very simple sum.